Hi everyone, welcome back to the channel. Today we're exploring an exciting development in the world of brewing, how science is helping secure barley, the backbone of beer, against climate change. Carlsberg researchers have recently identified a gene that could make barley more resilient to pre-harvest sprouting, which is a major threat to both farmers and brewers. Now, beer might feel timeless, a tradition stretching back thousands of years, but the ingredients that make it possible are under pressure. Barley isn't just another crop, it's the foundation of the malting process, the element that turns a simple grain into fermentable sugars. And as the global weather becomes less predictable, safeguarding barley is fast becoming a priority for scientists, brewing companies, and farmers alike. In this video, we'll delve into the science, the implications for brewing, and what this breakthrough could mean for the future of your pint. Whether you're a brewer, a scientist, or just someone who enjoys a well-poured beer, there's lots to get excited about.
It's Monday, don't groan, don't fear. The Bearded Beer Blog bloke is here. Talking nonsense, beard on show. Grab a brew and watch him go.
Brewing depends on barley, and barley depends on stable weather. But climate change is making extreme rainfall, heat waves, and unpredictable seasons more common. These conditions create stress at every stage, from planting to harvest. Barley prefers cool, dry conditions. Too much rain during sensitive periods can affect its quality. Extended heat waves can reduce yields or force early harvesting. Even small changes to temperature and humidity can disrupt the delicate balance that maltsters rely on to generate consistent enzyme activity. For breweries, this isn't just an agricultural problem, it's a potential crisis for supply chains, quality, and cost. A single bad season in a major barley growing region can send global prices soaring. Craft brewers, who often depend on specific malt profiles, can struggle to maintain flavour consistency. Larger brewers may be forced to shift sourcing across continents, increasing transport emissions and reducing sustainability. What's happening now is a signal. Climate volatility is no longer a hypothetical future threat, it's shaping beer today. One of the biggest issues is pre-harvest sprouting. This happens when barley grains start to germinate on the plant before harvest, usually triggered by rain and humidity. Let's break that down. Barley seeds are supposed to germinate once they're safely in a controlled malting environment. Malting intentionally activates enzymes that convert starch into fermented sugars for brewing. But if sprouting starts too early on the field, the process becomes uncontrolled. Enzymes activate too soon, starches break down prematurely, and the grain loses the qualities that make it suitable for brewing. Pre-harvest sprouting can reduce grain weight, damage starch reserves, and disrupt the malting profile. For maltsters, sprouted barley behaves unpredictably. For brewers, this can mean inconsistent flavours, lower alcohol yield, and hazier beers. In severe cases, entire harvests become unusable, not only for malting, but even for animal feed. And with rainfall patterns changing, the frequency and severity of sprouting events are rising. Enter Carlsberg's breakthrough. Researchers discovered a gene called MKK3 that regulates seed dormancy, the period during which a seed remains inactive until the right environment cues trigger germination. The team examined barley varieties from around the world, mapping which ones held up best under wet conditions. What they found was a clear genetic signature. Certain versions of the MKK3 gene make barley less likely to sprout before harvest, even during heavy rainfall. This wasn't just an accidental find. It builds on decades of barley genetics research, bringing together molecular biology, breeding trials, and global crop data. It's a classic example of modern plant science, targeted, evidence-based, and directly useful to farmers. In short, the MKK3 discovery turns a vulnerability into an opportunity. In simple terms, MKK3 affects how long seeds stay dormant. With the right genetic variant, barley seeds stay asleep until harvest, preventing premature sprouting. Dormancy is a balancing act. Too much dormancy delays malting, making the grain harder to process. Too little, and the grain sprouts in the field. MKK3 helps fine-tune that balance. Think of it as a biological timer that tells a seed, not yet, wait for the right moment. In resilient varieties of the gene, that timer is set longer, holding off germination even when rain and humidity create perfect sprouting conditions. For farmers, this means more reliable crops. For maltsters and brewers, it means predictable malting behaviour, and that translates into consistency in flavour, colour, and aroma. So why does this matter for brewers? Barley quality isn't just a preference, it's a requirement. The enzymes and starches inside the grain dictate everything from fermentability to beer clarity. If barley sprouting becomes more common, brewers may have to adjust recipes, switch malt suppliers, or accept variability in final products. Consistent barley quality means more consistent malt, which means your favourite beers taste as intended. It also protects the heritage and character of beer styles that rely on specific malt processes. Think Munich malts in a Marzen or pale malts in an IPA. There's a business angle too. Supply chain instability increases costs, especially for smaller brewers who can't hedge risk in the same way the big players can. A resilient barley strain reduces volatility and helps breweries plan long term. This breakthrough also has sustainability benefits. Less crop loss means less waste, lower economic risk for farmers, and potentially a reduced environmental footprint. Every time a crop fails, land, water and fertiliser have been used with no return. Preventing pre-harvest sprouting means those resources are used more efficiently. Economically, resilient barley varieties lower the chance of catastrophic crop failure. Farmers have greater confidence planting barley even in regions that have become wetter and more unpredictable. For brewers with sustainability goals, like reducing transport emissions or sourcing more locally, having a stable local barley supply becomes much more realistic. This isn't about survival, it's about strengthening the entire brewing ecosystem. Looking forward, the use of MKK3 variants could become standard in barley breeding programs. As genetic tools become more precise, it may soon be possible to develop barley lines tailored to specific climates or even specific brewing styles. Imagine a world where brewers can choose from climate-resistant varieties designed for pilsners, stouts or lagers, each with optimised enzyme levels and flavour outcomes. This gene could also act as a building block for more complex resilience traits, drought tolerance, heat tolerance and disease resistance. Stack several of these traits together and you have a barley that can thrive in regions currently considered marginal for production. For breweries, this is future-proofing. It's investing in ingredient stability and a world where the climate is not staying still. Carlsberg's discovery isn't just about beer. It's part of a wider movement in crop resilience. Wheat breeders have long been fighting the same pre-harvest sprouting problem. Sorghum breeders are developing lines that withstand drought. Maize researchers are exploring root systems that capture water more efficiently. Seed dormancy is a universal agricultural challenge, especially for cereals. MKK3-like genes exist in multiple species, which means this research could inspire parallel development in other crops. If we solve sprouting barley, we may solve it in wheat. And if we solve it in wheat, we support food security worldwide. Beer may be the headline, but the wider story is about feeding a changing world. Of course, breeding and genetics raise questions. One concern is access. Will small farmers benefit from these improved barley varieties, or will they be limited to large-scale commercial growers? Ensuring fair distribution is key to global resilience. Then there's the question of regulation. Some regions restrict the use of genetically modified organisms or gene-edited crops. While many barley breeding programs rely on traditional selection rather than genetic engineering, public perception still matters. We also need to avoid putting too much emphasis on a single trait. Crop resilience should always involve diversity in genetics, farming practices, and landscapes. Relying solely on one gene could create new vulnerabilities. Ethics and science must evolve together, or we risk solving one problem while creating another. For beer lovers, this research is a quiet but important victory. It helps ensure that future batches of your favourite brew remains consistent, high quality and sustainably produced, even as climate change grows. You may never see MKK3 printed on the label, but you'll taste its benefits in the clarity of a lager, the balance of an ale and reliability of seasonal releases. It's a reminder that every pint is a product of agriculture, science and centuries of innovation. And that wraps up our dive into Carlsberg's barley breakthrough. Science is helping secure the future of brewing one gene at a time. If you found this fascinating, please hit like, subscribe and comment on what brewing or agricultural innovations you'd like me to explore next. From yeast genetics to sustainable hops to the chemistry of foam, there's a whole world of beer science waiting to be uncovered. Cheers to resilient beer and see you next time.